Welcome back, everybody. In this video, we're going to be taking a look at our next IKev2 topic, which is going to be GRE over IPsec with the crypto map variation, where we're going to be configuring a GRE tunnel between CSR3 and CSR4. And then what we're going to do is we're going to send the traffic over. We're going to ping and do EIGRP routing and that type of stuff. So we're going to do a little bit of EIGRP routing up in here, and then get this up and running so that the reachability is there. And then what we're going to go do is a GRE tunnel. Actually, you know what I need to do that I haven't done yet is move this over here. I need to open up Bing2Go because I want you guys to see what I'm talking about. Give that a second to fire up. There it is. So we want to do connectivity where we do, let's do a line, and I'll do red. So right now, the way we have stuff set up is we have tunnels set up from here to all of this, and then we have communication going over that. Pretty straightforward stuff. Well, what I want to do is I want to add, instead of just doing the crypto map variation where there's no actual IP address, we're just encrypting whatever matches on the ACL, I'm going to go and do a tunnel where I'm going to go grab a, let's do this. Let's do a line to here. Actually, let me do it to 6. Yeah. No, let's do it to 4. And go to here. And let me flip over. This will be an ellipse. Just draw this out real quick. So we have this tunnel here, and we have a tunnel here. So when we go to configure the GRE tunnel itself, we should be able to send pings over the tunnel and do all that type of stuff. So let's go and do that real quick. So we'll pull up our configuration here. We'll move this out down here. And so on CSR3, which I don't have pulled out at the moment, let's go pull up CSR3, open him up real quick, and we'll go bring him all the way over here. So CSR3, I will go to global config, interface tunnel, and we'll call this 34. Tunnel 34, the tunnel source will be gig1, the tunnel destination will be 41.0.0.4, the IP address in this case here would be 10.3.4.3/24, and we'll go to CSR4, interface tunnel 34, tunnel source is gig1, tunnel destination will be 31.0.0.3, IP address will be 10.3.4.4/24. And then what we'll do is we'll go and on CSR3 do show IP route 0.0.0.0, just a quick default route 31.0.0.1, do ping 41.0.0.4. We can ping it, which is great. Now what we're going to go do is the line protocol came up on this guy, so we're good to go there. So I'm going to go to CSR1. I'm going to close this guy down. I'm going to click on here, capture on gig 2, because we're going to need to look at a different variation of Wireshark. I'm going to move that off screen for the moment. Let me go ahead and finish getting the rest of the config up and running. So what I'm going to go do is, we have the GRE configuration in place. I'm going to go router EIGRP VPN, address family IP4 autonomous system 1, network of 10.4.8.0, 0.0.0.255, and we're going to network of 10.3.4.0, 0.0.0.255. And then we're going to go over to CSR8. We see EIGRP hellos going across the wire. Well, actually, you don't actually at the moment. So let me clear the screen off real quick. Whoopsie, that's not what I meant to do. So we have that. Then we're going to go router EIGRP VPN, address family IP4 VRF-S4 autonomous system 1, network of 10.4.8.0 0.0.0.255. So we form an EIGRP adjacency with CSR4. I'm going to go router EIGRP VPN, address family IPv4 autonomous system 1, network of 10.3.4.0 0.0.0.255, and network of 172.16.1.0 0.0.0.255. And then I'm going to take, and you can see I've got EIGRP adjacencies going over the wire. So that's a clear indication that this communication is unencrypted. So I'm going to go over to CSR7 and router EIGRP VPN, address family IPv4 autonomous system 1, network of 172.16.1.0. We'll go ahead and do that. And then I'm going to go on to CSR3 and I'm going to type in topology base redistributed static with a metric of some ridiculously high value, just to get traffic to go the way that I wanted it to. That'll get over to 7. And then do show IP interface brief, and I'll type in network of 10.1.0.0 0.0.255.255. And what will end up happening now is CSR4, do show IP route. I should be receiving a bunch of routes from this guy, and on CSR8, if I do show IP interface brief, if I type in network of, let's see, 172.24.0.0 0.0.0.255, and network of 192.168.40.0, sorry, 192.168.40.0 0.0.0.255. What's cool about this is on CSR7 now, do show IP route, I'm going to see all these routes coming across the wire. So I should have end-to-end reachability through dynamic routing. So we're going to keep this up and running until we need to modify the config. So what I'm going to do now is on CSR7, I'm going to ping 172.24.0.8, sourcing from, in this case here, loopback 0. And so, let's see, CSR8 must not be learning it. Show IP route, VRF-S4. Oh, he's definitely learning about it. Seven. Trace route. Oh, 24, not 48. Or 24, not. There we go. That's better. So now I can ping, so I'm going to do a trace route to that same setup. But the point that I want you guys to see is that I can send traffic across the wire, clear text, right? So what I'm demonstrating through this whole situation is I can see everything that's happening. And we're capturing on the internet-facing interface. So the internet that we're simulating here can see all of this. So now what we're going to go do is configure a IPsec VPN, a GRE over IPsec, with the default IPsec transform set with EIGRP. So what I'm going to go do is pull this back up, and on CSR3 we're going to begin this config. So we have all the routing in place. The next thing we're going to go do is type in IP access list extended is called IKEv2 GRE over IPsec and permits GRE any. So that's the only thing we have to do. Is right there. That matches on everything we need to match on. Normally you would not do this with a crypto map. Normally you would do this with an IPsec profile, which we'll be doing in the next video, but I want to demonstrate how this works. So I'm going to go to crypto IKEv2 keyring. The keyring name is going to be IKEv2 GRE over IPsec keyring. We want to make sure we know which keyring maps to which particular example. So peer is going to be CSR4. The address is going to be 41.0.0.4. The pre-shared key local will be CSR3. The pre-shared key remote will be CSR4. We're going to jump out of this config. Crypto IKEv2 profile will be IKEv2 underscore CSR3, CSR4. We'll do GRE over IPsec profile. I don't know if I'm running out of character. Yep. Oh, okay, that'll work. We're going to do that, and then we're going to say match identity remote address is going to be 41.0.0.4/32. Then we're going to type in the identity local address is going to be 31.0.0.3. Authentication local pre-share key. Authentication remote pre-share key. And then we're going to type in the key ring local and then this really long name right here. That's that. Next thing we need to do is we need to type in the crypto map CMAP. Local address is going to be gig1. That's where we want to source this traffic from. Crypto map CMAP. Entry number 10 IPsec ISACamp. We're going to say match address all the way back up here. Where is the access list? We're going to set the peer to be 41.0.0.4, and we're going to say set IKEv2 profile to be this profile right here. And then that's all we have to do. Interface gig1, crypto map CMAP. That'll get that ball rolling. Now what we're going to go do is we're going to come back to Wireshark and we're going to lose connectivity. What I want you guys to see is this right here. Bring this down just a touch. We're going to see traffic from 4 is sending the hellos, right? But now what we're doing is this information right here is saying we received a message inbound from 4 saying that I'm trying to send messages via GRE and it was received a not IPsec. So that means I have to go do this exact same config on CSR4. So the CSR4 config is very similar. We're going to type in IP access list extended is going to be IKEv2 GRE over IPsec ACL permit GRE any. If I wanted to be more specific, I could put endpoints in there, but I'm preferring not to do that. I'm now going to type in the crypto IKEv2 keyring of IKEv2 GRE over IPsec keyring. The peer will be CSR3. The address will be 31.0.0.3. The pre-share key local will be CSR4. The pre-share key remote will be CSR3. Exit out of that. Exit out of that. Crypto IKEv2 profile will be IKEv2 CSR3 CSR4 underscore GRE underscore over IPsec underscore profile, and then we're going to say match identity remote address of 31.0.0.3/32. We're going to set the identity local address is going to be 41.0.0.4. And then we're going to go authentication local is pre-share key, authentication remote is pre-share key, keyring local, and then we're going to grab the keyring name like that, IPsec, that'll work. And then we're going to go crypto map CMAP. Local address is going to be gig1, and the crypto map CMAP 10 IPsec ISACamp. Actually, in this case, there's going to be 20. 20 IPsec ISACamp. We can't use 10 because that's using the connection from CSR4 to CSR2. So keep that in mind. I'm doing multiple peerings in multiple different ways to show you could have multiple variations of the setup, because very likely you could have this in production. So we're going to go ahead and set the peer to be 31.0.0.3. We're going to set the IP2 profile to be this really long name right here. And we're going to say match address, and the address is going to be way up here, like that. And then we're going to go to the connection. It should, there it goes. So by doing the configuration correctly, we were able to get the connection up and running. Now we're strictly ESP. The adjacency is now online. If we go back to CSR3, we can see that the adjacency is up. If we were to do a, let's go ahead and validate this. And we're going to say that show crypto IKEv2 SA. We have one going to router 4. Show crypto IPsec SA. Pipe include peer. PKTS ident. We can see everything's going across. If we hit the up arrow, we're going to see packets going across. Show IP EIGRP interfaces. We're enabled on gig 2 and on tunnel 34. Show IP EIGRP neighbors. I have an adjacency with router 4. Show IP route. And I have routes going across the wire, which is what I want to see. Now if we go back to CSR7 and I hit the up arrow a couple times. Let's do a show IP route. I have a bunch of routes that I've learned in, and if I do that trace route again, I still get across the wire, but you notice that it's all ESP. I don't see anything but ESP. And that's the point that I wanted you guys to see. There's really nothing spectacularly difficult about any of this configuration. But it's one of those things where when you're going along and playing with it, you got to dig into the details. I like having the Wireshark capture so I can see what's happening on the wire, because the wire doesn't lie, right? Now, I might not be 100% accurate on everything that I say 100% of the time, or I might get things out of line or whatever the case might be, but this helps me to prove if I say that it's going to be clear text, I can show you it's clear text. So I can't formulate packets that fast, so not that good. With that being said, ladies and gentlemen, that is going to be GRE over IPsec with a crypto map with EIGRP adjacency. And if you notice that we're using the default transform set. So if we go back to CSR3 and we look at the show run section crypto map, we don't have a IPsec transform set called. We're calling the profile and the address show IP access list. We have 16 matches. So that means the traffic is working the way that it's intended to, and everything is going along that we need it to do. So with that being said, ladies and gentlemen, thanks so much for stopping by and hanging out with me in this video, and until next time, take it easy.